Hello, folks. I'm Neal,
I'm Davide.
and here we are once again to give you a glorious update on what we do in the Hyperscale SIG.
Quick agenda for today. As usual, we'll start with a recap of what the SIG is and what we do. We'll talk about recent work, and we'll close with what's coming down the pipe.
Yeah, so the Hyperscale SIG has obviously a focus on CentOS Stream. But we're all here for because CentOS Stream is cool and awesome. It focuses on people doing deployments in large-scale fashions, like either in servers or desktops or whatever. But the other goal here is that folks that are doing large-scale deployments can come into one space and collaborate on packages and tooling so that they benefit from, the shared knowledge and space. And because, we want to also encourage people to develop this stuff out in the open so everybody can leverage it with each other and not duplicate work when it is completely unnecessary. And it's open to anybody who's interested in working the space. It's not just for super large companies or the hyperscalers or whatever, although all those people are obviously welcome. I do not belong to a very large company. I belong to my company, Velocity Limitless, and do work in hyperscale on behalf of that. So clearly, it's not just for the big uns. It's for everyone. The SIG Health, we were established in January 2021, which is just shortly after the shift to CentOS Stream, with 6 founding members, me, Davide, Michelle, and a few others. As of today, we have nearly 40 members. Okay.
We do. I counted it right before.
Oh my gosh, it keeps going up.
And yes, that's what happens when you onboard new people.
Yeah, you're not wrong, but it surprises me. We have a matrix room where we do most of our day-to-day as CentOS Hyperscale on the Fedora project server. We have bi-weekly meetings on Matrix. We have monthly hackathons and video hangouts and meetups that we try to do adjacent to events where we're all coming together. We did one, I think, at CentOS Connect. We did one sort of, I think, at Flock. No, we didn't do one at Flock. We did one sort of for DevCon CZ.
Yeah, I think the next one will be likely Connect FOSDEM next year.
Yeah, I don't know of any other time where we would meet up together. But yeah, we do those occasionally, and this is an opportunity for to hang out and stuff. Maybe we should do one at scale. That might actually not be a terrible idea.
Fun.
Yeah.
No.
Yeah, and so as part of the SIG being, a team of people doing lots of different things, we have our charter and documentation as well as our activity reports, and we try to make sure all of our talks are listed. So you can go back and see how many times Davide and I have given this talk, among other things.
Actually not up to date right now. I'm going to try and get that tidied up in the coming weeks because I finally came up with a reasonable way to track conference talks because we have far too many.
Yes.
But yeah, we will get that sorted out. We also need to clean up the issue tracker and likely move it to GitLab with the rest of the infra at some point in the future.
Yeah, well, there's a bunch of revising. This presentation will get a lot more changes in the coming months because of all the stuff that's going on. So our Hyperscale SIG scope, some of it is faster moving package backports and stuff, which Davide will get into in a bit, as well as configuration alternatives, policy stuff, large scale testing enablement, custom kernel, and of course images for workstation and cloud deployments. So Davide, you want to talk about backports?
Let's talk about backports. So the idea behind backports is to provide packages for CentOS Stream that are drop-in replacement for the packages that are in the stock distribution, but provide additional functionality. You can get these on a stock CentOS Stream system if you DNF install CentOS Release Hyperscale. If you use these packages, please do not file bugs upstream because people will be very confused. Please file bugs in our tracker. The assumption if you use Hyperscale is that you're going to be using Appel, and we build our content against Appel. Well, partly because that saves us from doing duplicated work, but also in real-world deployments, there's very few cases where you don't want to run Appel. We target x86-64 and ARC-64. We could potentially target more architectures, but these are the only ones we can actually test on. So if you really like S390 and you want to have support for that, please talk to us. We can figure something out, but we don't want to support things that we can't actually test against. There's a long list of packages we do ship that you can look at the links. That's just a random selection of things that came up recently. Also, things we're working on are an OpenSSH backport based on the patch set that Meta has internally. That one is, the sources are published there. We don't build packages for this yet because it's still a bit iffy and we would like to get more of these upstream. We also have work on the virtualization stack that I'll talk about in a little bit later. Next slide, please. We used to have a pipeline to track automated updates for this package. Unfortunately, it is completely broken right now, and we still have not had a chance to rewrite it. So hopefully this slide will be better the next time we do this talk. Next, please. Talking about backports, one of the main packages we provide is systemd. The idea behind systemd is to provide the latest upstream major release. Currently it's 256, 257, and soon 258. We ship builds for CentOS 3.9 and CentOS 3.10, and we ship feature-full builds with all of the upstream features enabled. So we ship even things that RHEL itself doesn't ship. So we ship UMD, we ship NetworkD, we ship ResolveD. We ship the journal with a variety of improvements, especially around copy on write file systems. In general, this is meant to track very closely the Fedora Rawhide build of systemd. This does ship with SE Linux enablement. However, I don't run SE Linux in production. I'm not aware of that many environments that use these packages with SE Linux in production. So the SE Linux support might be a bit wonky. I would say the support for the core features of systemd is probably fine, but you might encounter issues if you try to use some of the more like fringe features, like say HomeD. This is definitely an area where we would welcome contributions and help from folks.
Yeah, and I would actually make the additional point that very recently we have moved towards backporting SE Linux policy from Fedora. So Hyperscale includes the full SE Linux policy package from Fedora. So anything that you experience here is probably the same in Fedora, and contributing into Fedora's SE Linux policy to fix things can benefit both Fedora and Hyperscale. So
okay, that should actually be much better to maintain.
Yeah. I think we can actually drop the experimental label because we're no longer doing the other thing. But because I run CentOS Hyperscale with SE Linux enabled on all of my systems, and I really don't have any issues anymore. Ever since we switched to, at the same time we moved to a new systemd version, we pull in a new SE Linux policy from Rawhide as well. So we're moving those in lockstep these days.
I should try it again. I have it running at home, and I had to turn it off because I had issues with NetworkD, but maybe it works fine now. I'll give it a try.
Yeah.
Next slide. As I mentioned, the packaging for this is based on Rawhide. We actually try to contribute any changes we might need to do in the Rawhide specs with the appropriate gating so that everything is in one place. One of the things we contributed a few months ago, for example, was a test runner and logic, so that we could run the tests we needed on the Rawhide side. This package is maintained on the Hyperscale side. This is maintained in GitLab. It uses all of the GitLab features that are available. In particular, one thing we leverage extensively is pipelines, and I'll have an example of the pipeline a little bit. But the other thing we have in addition to this is another repo on GitLab, which is the systemd sources with all of the patches applied. So it's basically a flattened repo with all of the patches applied. And the reason we have this is because it makes it very easy to do like development and debugging if you need to quickly get a package without having to grab the RPM and apply the patches manually. And this is kept up to date automatically via pipelines as well. And by the way, the approach we use for this is generic, so you could potentially use it for other packages as well if you wanted to. Next slide, please. This is a screenshot of the pipeline I mentioned. So for systemd, every time there's a commit to the repo, we have a series of pipelines that do builds for both 9 and 10. They run the build, they do the testing, they then publish the build, meaning they issue a build in CBS and tag it, and then they update the unpack repo that we mentioned before. So this gives us, it runs effectively the same test suite that Upstream runs. So it gives us a fairly good and extensive smoke test of the build itself. Next slide. And in CBS, you can see all of these daily builds are actually built in CBS by a bot account. So you can fetch them if you want. And in fact, we do ingest these in Meta in our environment and run additional tests on these in production against internal services. These are builds based on Git main. So we basically take the packaging that I just mentioned, and we do a build of today's systemd Git main. And this way we can know ahead of time if there's issues that are going to be coming down the pipe or things we might need to fix in the packaging or upstream. We have a long-standing discussion of potentially extending this to also use OpenQA, but that hasn't materialized yet. Next slide. I mentioned before virtualization. So we use a similar approach for the virtualization stack, where we maintain updates of the latest virtualization stack coming from Fedora. So we have QEMU, and right now is QEMU libvirt a few supporting libraries. We might extend this to libguestfs in the future. These uses, it's not the same CI the system uses, but it's the same approach, and the code is very similar. We haven't quite evolved this yet into a generic CI thing. So right now, this is sort of copy pasted from the system one. But we were looking at ways we could do this in a more generic fashion so that multiple packages could reuse it.
Yeah, I mean, I think one of the things we may want to extend this to is our forked Anaconda stack, because that is important to make sure it doesn't break.
Yeah, for sure. I think we could do, at the very least, doing build, run the tests flow. We could likely turn that on for any package, and I think it would provide at least like some level of signal. If you wanted to do additional testing, I think that's something we might need to customize per package. But at the very least, a baseline would be nice to have everywhere. And this is something other SIGs could leverage too.
Right. Yeah, we're building a lot of this stuff with the idea of it being reusable, as will come up over and over. So this one is the Apple Silicon support. So we now have CentOS Stream Hyperscale for Apple Silicon Macs. This is kind of based on the work that we did for Fedora Asahi Remix with the upstream Asahi Linux project. So we use the Fedora Asahi Remix copper for downstream packages like U-Boot and EPEL for everything else. We have daily builds. We don't have a formalized release just yet because there's still things to pin down, but you could try it if you'd like.
If you try these, I would say you probably want to try the dailies, because the /SI endpoint is meant for the stable builds, and right now there's just one build there, which was the very first one we made when we went at a summit for testing. We haven't had the time to actually qualify the dailies to promote them. Last time I tested these, it worked well enough that you could boot to KDE and use it. There's definitely some rough edges. Not all of the user space packages for enablement are branched just yet. So things like, for example, the touch bar on some of the MacBooks isn't enabled yet. But the goal is eventually to get the same level of feature support that we have in Fedora, because we're using effectively the same stack. Another thing we've been working on recently is experimenting with ELN. Fedora ELN, if you're not familiar, is you can think of ELN as if we were taking Fedora Rawhide today and making CentOS Stream from it now. So it gives us a preview of what the next CentOS Stream major release will look like. And we use ELN extensively at Meta for testing to get signal about what the next CentOS Stream major release would be. But one issue with using ELN is that ELN is just the content that's shipping CentOS Stream plus a subset of EPEL via ELN extras. We didn't have a good way to have SIG content there, and we can't target ELN from CBS because CBS doesn't have access to the ELN build routes. So we looked at using Copper for these instead, and the idea was to build in Copper a subset of Hyperscale targeting ELN so that it can be tested alongside ELN. To do this, I spun up a couple of Coppers, one for the main tag and one for the Facebook tag. The main reason I put the Facebook tag there was to experiment with having layered repos. That's not something that's going to be useful for general use, but it's a good example of how to do it. The way Copper works, you can't in CBS you can have macros override, so you can just define them using a Koji command. You can do that in Copper. So the way we do the overrides in Copper is by installing a custom Red Hat RPM config package, and we had to build that and maintain it on the Hyperscale side. This does work in the sense that it builds and the package is installed, but I only got this working literally last week. So I would not recommend using this right now, but it is something that I'm hoping we'll be able to productionize in the coming months. Next slide, please. We had to fix a fair amount of things for this to work. On the infra side, we had to work on allowing SIGs to override this prefix, because otherwise the packages would come out with the wrong this tag, and it was very confusing. This led to the discovery that we could actually streamline quite a bit this setup, and ended up creating a more streamlined setup for all of the SIGs. I think on the Hyperscale side, we had to make this Red Hat RPM config Hyperscale package, as I mentioned, shipping our macros. We also found a bug in our systemd package, in that in our systemd package, we're using conditionals to only include some patches in the sources for some tags. And that led to our source RPMs that were different if you were building against main versus against Facebook. And it turns out that, well, it's not something you should do, period. Like, that's a bad idea. But also that breaks Copper horribly, because when Copper builds the source RPM, the macros aren't defined yet. Which I couldn't quite figure out if that's a bug or a feature, but either way, what we were doing was wrong. And Michelle was very helpful in fixing that in the packaging on the Hyperscale side.
It's
on
basically
the Copper
both.
Side, yes.
It's basically a bug and a feature. It's not good. It shouldn't work that way, but
yeah, it is what it is. On the Copper side, we work with the Copper folks to add support for building against the CentOS Stream dskit for SIGs. Copper already supported building for CentOS Stream against CentOS Stream sources, but it didn't have a concept of the dskit for the SIG specifically. And the dskit for the SIGs is distinct from the one for CentOS Stream because SIGs use a different place for the Luca side. So this required some integration work in Copper and adding support to the database there. And now you can actually build any Copper targeting SIG content hosted on GitLab. Copper still does not support doing automated rebuilds for this content, though. It only supports doing automated rebuilds for content on source.fedorproject.org at the moment. I filed an issue with the team, and we're discussing their potential approaches. There's other ways to do automated rebuilds, like you could use Packy, you could use other solutions. So this isn't necessarily a showstopper. The other issue that we've been working on is that right now we don't have a good way to track whenever ELN does a mass rebuild. And because ELN is rebuilt fairly often, we want to have a way to kick off a rebuild of these Coppers whenever ELN is rebuilt. Otherwise, the Copper content will be lagging and potentially become uninstallable. That's something we've been discussing in the ELN meeting, and we filed an issue for tracking. We don't have a good dependency, a good solution for that yet, but we'll get there. Next slide. You want to do this one, Neal? You're muted.
Yep, there we go. Hi, I exist now. For CentOS Stream, as part of Hyperscale work, we've contributed to CentOS Stream because it's not just about us doing add-on stuff. We also want to take advantage of the fact that in CentOS Stream, we can do things to CentOS Stream itself to make things better for us. So with CentOS Stream 9, very, very early on, we did a fair bit of work that actually turned into like top-line features for RHEL 9. For example, there's a big list here, but I want to highlight that, for example, Pipewire being used as the sound subsystem in RHEL 9 and 10 came from us originally with CentOS Stream 9. The Wayland support for GNOME Classic, as well as SDL running in Wayland, that was also us. There's other miscellaneous things like being able to package up third-party Nginx modules, which I know some people use because it gives you nice functionality. And of course, our UMD stuff that Davide brought in. And there's miscellaneous like package updates here and there. And the story is similar with CentOS Stream 10. We kind of took what we were doing before and we kept doing more of it. So improvements to the branding packages to make things easier for us as a downstream of CentOS Stream. libportal, introducing and updating libportal and various things that are needed for being able to build stuff, building Wayland compositors and things like that. Having the AR64 targets for the Rust compiler, for Fedora, for Hyperscale SIG, and stuff to fix, SSL certificates. This is a short list of like the most cool things, but there's a lot of random stuff too that we've done in that. And this is something that we've continued to do as part of building a better CentOS stream, as part of building a CentOS stream hyperscale. And kind of circling back on top of the building and the testing. Davide, run.
We're running out of time, but like a quick roundup of the other things we have been doing. We have our dedicated repo for doing large-scale testing of features we want to try out in the distribution but aren't quite ready. And a good example there is the DNF RPM copy on write work, which we do not have time to talk about, but we've talked about extensively in the past.
There's enough.
The up.
And then
you see with this one.
Yeah, so hyperscale content collections. Earlier this year, I built a new tool, Kirchu. I've written a blog post about it. There's also a video about it from CentOS Connect where I gave it, I talked about it more in depth. the cool thing here is that now we can take all the disparate things and create testable units. As Davide mentioned earlier, we're trying to get into open QA testing eventually. This is a very important stepping stone for this. And we built this in such a way that other SIGs can also take advantage of this if they so want to. Like, I don't know if Overt is still doing the thing where they're part of the Vert SIG and doing stuff and things on top of it. Well, you can use Kurtchu to assemble, the releasable content collections for producing Overt stuff. Or XCPNG, which I think is built on CentOS and stuff like that, or anything else really, because it's not just for CentOS. You can do it with Fedora, you can do it with Alma, you can do it with whatever. You can even do it with RHEL itself. I did some testing about doing mirrors of RHEL with it, and it works pretty well. You do need to have to run it on a RHEL host because subscription manager, but it does work. Published composes we're working on doing automation and refining our definitions, but there you go. Also, this should have come before that, whatever. Anyway, so this is, as part of building the hyperscale experience, we have our own kernel. And it is not 6.12, it is 6.14 now, which is why I was confused for a second there. We were previously 5.14 because we were based on the CentOS Stream kernel. We are now based on Upstream. We basically rebased after Fedora, depending on test data to make sure that we're okay with it. And we built it for CentOS Stream 9 and 10. It has Btrfs and Wavedroid support. We are waiting on Secure Boot, and that link needs to change because I think the tracker moved to GitLab. It is available in the experimental repo for 9, and it is available in a dedicated kernel repo for 10. A couple of derivatives of CentOS Stream asked for being able to use the kernel without using everything else, so I split it out for them. No one had ever asked before, and so I never bothered, and someone asked, so here we go. And there's stuff we did as part of making this kernel, so we put stuff into the mainline kernel because we're good people, and we want to make sure that people benefit from as much of the enablement work we do as possible. And this has also resulted in Kmod Btrfs becoming a thing. It says it targets the stock Stream 9 and 10 kernel, Stream 9 kernel, but it also will target the Stream 10 kernel because that has resumed since we did the work upstream as well. We have user space stuff, which we've talked about before.
Yeah, on the user space side, we ship Btrfs support, Btrfs support in user space. Neal worked on restoring support in the installer as well, so that you can install CentOS Stream Hyperscale directly on Btrfs. We also ship kernel live patching via Kpatch that allows you the way to actually build your own kernel patches, and we ship a backport of kexec tools that helps with that.
The container image really hasn't changed all that much in the past few times. We build it by hand, we push it to because the CI doesn't work. We build it by hand and then we push it. We are trying to rejigger this. It is in progress. Live media, big change here is we now have Stream 10 images. We have a Stream 10 spin with KDE Plasma, in addition to the Stream 9 spins with GNOME and KDE Plasma. And it uses all the stuff we just talked about. Cloud images, same story, except for we're talking about OpenStack and generic clouds as well as AWS. Other clouds we can build, it's just we don't have any stakeholders who are interested in it. We have the capability to produce, for example, Hyper-V or Hyper-V/Azure, as well as Google Cloud. We're just not doing it right now because no one stepped up with any real interest in it. This stuff has actually gone back and influenced Fedora as well, because a lot of this stuff started here and then went into Fedora, and then Fedora's influenced back us. It's a whole thing. So what's new? This is not new. Linux.
That's fine. We can pick this one.
Yeah. And then coming up, we did the Apple Silicon thing as a preview. Final releases are coming. We have preview images. The Quivo thing is slowly in progress. Transactional updates as well.
Kimu, I think the hyperscale story for Kimu is pretty good these days. I don't think we ever quite figured out for doing a plain version in Appel. I don't know if that'll actually happen, but I still think it will kind of make sense. And transactional updates would be nice, but that still hasn't made it to the top of the pile.
Yeah, well, there's a lot of other things we have to do, but like having Quimu and Apple would fix being able to do foreign arch builds in mock, because that's currently blocked on not having a Quimu package in Apple. So these are resources and stuff. Matrix Room, we said earlier, we have an issue tracker, and you could also do it on CentOS develop mailing list. And that's it. We have a couple of minutes for questions, I think.
Well,
or not. I don't actually know.
Flexible. Depends on how quickly Troy sets up.
Okay. So there's somebody, I think, either clapping or raising their hand. I don't know.
I think
Alrighty.
But yeah, if you all have any questions, happy to answer them, or you can always find us in Matrix or at probably a random conference. Pat.
Oh, Pat.
So, are you guys at all concerned about what's going on in Systemd 258, where you can't set ownership of device nodes to higher group numbers?
Oh, what?
That is a good question. I have
That's
not
an ex.
looked into
I didn't
that
even know that.
specifically, to be honest.
I didn't even know that was happening. Oh no, that might actually be a problem. We will have to look into it.
Yeah.
It breaks stuff for me, and so I was just wondering if it broke things for you too.
Well, we are still on 257, so that's probably why we haven't noticed
I
it
can
quite
tell you,
yet.
I have not heard noise about it on the meta side, at least. But I don't know specifically about this thing, so I will ask around and find out.
Yeah.
Okay, I'll throw a thing into my complaints on. Yeah.
Yes, please.
Yeah, the one I'm watching out for, though I don't think any of us particularly are affected, is 259 is deleting the system 5 init generator. So init scripts are gonna basically just stop working.
I mean,
Unless
that
somebody splits it out into its own thing.
it's been 10 years. Like,
Yes, but we're talking about enterprise Linux where people move slow as balls.
still.
It's also been deprecated since 2.5 or
I think
2.4.
eventually we will get there. But yeah.
It's been deprecated since RHEL 8. That is how long it's been deprecated.
No, I think that could be interesting for like vendor software for sure. If you're installing proprietary software that comes from God knows where, that's going to be a problem. For open source only deployments, I don't
see an issue.
practically gonna be a problem. Like at this point, everyone that can ships a system service. If they can't, it's easy to add one downstream. So I think it'll be fine.
Yeah, I'm more concerned about people who integrate this with weirdo software rather than the stuff that we experience in the community space, because the weirdo software is the ones made by people who just don't pay attention to anything, or they try to abuse random crap about how sys5 worked.
the chat
Yes.
is commenting on this as well.
Oh yeah, and Michelle, you're right. Like, it's only been deprecated in systemd itself since I think, like, was it 250? I think 250. But yeah, Red Hat has declared it.
But yeah,
But Red
not
Hat has
too long
declared.
ago.
Yeah, but Red Hat has declared it deprecated since RHEL 8. So people need to get on board at this point. Not that I don't have sympathies for, maintaining some kind of way to do it externally. I mean, there is the generators and stuff, but anyway, I think that's it for us.
Yep, I think we're at time.
Yep. All right. Thanks, guys.